Hey guys, welcome back. So till now we have got an overall idea about the sorting chapter. Now with this video, let's start to learn all the sorting algorithms one by one. So the first type of sorting is a bubble sort, which is basically the simplest of all the sort. So let's see what exactly is bubble sort. So a bubble sort sometimes is also called as sinking sort. Now what we exactly do in bubble sort is very simple. So we go through the list of the numbers to be sorted repeatedly, and every time we compare each pair of adjacent items and swap them only if they are in the wrong order. Now what that means is, let's try to understand using a simple example. Now let's say these are the numbers that we want to sort. So as we can clearly see, these numbers right now are not in sorted order. So let's say we want to make it in ascending order. So how do we do that using bubble sort? We will take each pair of items and do some comparison. So we'll take the first two pairs and do a comparison. Whichever is the bigger element among these two will come second and the smaller will come first. So here we see that 10 is smaller than 30. So it needs to go towards first and this needs to go towards second. So this is how it will look after the first step. Then we again do the same thing with the second pair. 50 is more than 30, so we need not do anything. Move on to the next pair. 20 is less than 50, so we need to swap. So we'll put 20 over here and 50 over here. Now again we'll do the same thing for next pair. 60 is more than 50, so nothing needs to be done. Again we do the same thing. 40 is less than 60. So we need to swap. So 40 will come here and 60 will come over here. So after one iteration, if you observe, we have found the biggest number in this set of numbers, which is 60. And we have put it at its right place, that is the last cell of the array. So now as we would have guessed, 60, since it is at correct position, we need not do any more computation on this. So next time when we run the loop, we run from first till the second last and we will not touch the last cell. Similarly, when we get the second biggest element, then we say this number is the second biggest, so we will not touch it anymore. So in that case, we again run this loop from first to fourth. Similarly, 1 to 3, 1 to 2 and 1. Now we again need to run this loop for the second time from the first element till the second last element. We'll do the same thing. We will compare the two adjacent items. So 30 is more than 10. Nothing needs to be done. Next item, 20 is less than 30. So we need to swap. Now we go to the next item. 50 is more than 30. Nothing needs to be done. Next item, 40 is less than 50. So we need to swap. Now after completion of the second iteration from first element to the second last element, we see that this second last element at its right place, that is 50, which is the second highest element in this all elements. So again what we'll do, we will freeze it. So we'll say 50 is done. So next time when we run the iteration, we will not include 50. We will run only till here. Now we again do a comparison. 20 is more than 10. Nothing needs to be done. Again do a comparison. 30 is more than 20. Nothing needs to be done. Again a comparison. 40 is greater than 30. Nothing needs to be done. So we'll say 40 is done. So now we have got the third biggest element in this array. Now we again do a comparison. 10, 20. 20 is more than 10. Nothing needs to be done. 30 more than 20. Nothing needs to be done. So 30 is our fourth biggest element in this array. Now we again do a comparison between these two elements. 20 is more than 10. Nothing needs to be done. So 20 is now the fifth biggest element in this array. Now since we are left with only one element, we need not do any comparison. We'll leave it as it is. So 10th automatically becomes the sixth biggest element in this array. So now if you see, this array is sorted 10, 20, 30, 40, 50 and 60. So all that we have done is, we have created two loops, and in every loop we made sure that first we get the biggest element, then the second biggest element, third biggest element and so on. and when there is only one element left in the array, then we are done with the entire sorting. Now let's see how does the algorithm for this looks like. So the algorithm is simple. It takes the array on which the sorting needs to be done. N is equal to the length of the array. Here we have two loops. One is outer loop, one is inner loop. Outer loop basically makes sure that we first get only the biggest element, then the second biggest element, third biggest element, fourth biggest element, and so on. The inner loop is responsible for doing all this comparison between the two elements. So that's what we are doing here. That is, if the current element is less than the previous element, then we simply do a swap. Else we need not do anything. Fine. So I hope you have understood the algorithm. It is extremely simple. Now let's see the time and space complexity of this algorithm. So here we have two loops, and both of the loops typically runs for n number of times, and rest of the operations are constant time operation. So if we multiply these two loops, because they are nested loops, it becomes n into n, that is n square. So time complexity is n square. Space complexity is order of 1 because we are not using any extra space for doing the sorting. It's a in-place sorting algorithm. So that is all about the bubble sort algorithm. Now let's quickly see that in which scenario should we prefer a bubble sort algorithm and in which scenario we should not use it. So we can use bubble sort in three cases. That is, when input is already sorted. In those cases, bubble sort is very efficient. Secondly, if space is a concern, in that case also we use a bubble sort because bubble sort does not uses any extra space. And the third reason is bubble sort is extremely easy to implement. So if our data set is small, we should be using bubble sort. However, in case if we are very particular about the time complexity, then we should not use bubble sort because bubble sort runs for order of n square time, and if the data is really huge, in that case it can take a lot of time to do the sorting. In those cases, there are other better sorting options which can do in way better complexity, like order of n log n, as we will see in some time. Fine. So that is all about the bubble sort algorithm. In the next video, let's see one more sorting technique called selection sort.